Hello, it's been a long time since I've looked at this video recorder. It's a JVC HR2200. I did a video on it a few years ago now. That was part 1. I never actually did a part 2, so I thought I'd do one now. In that video I replaced the cassette lamp, and there was also a dodgy switch. I think it was the on-off button. And I just wired it closed. At the point I left it, it was refusing to load a tape and the battery light was on, even though I was running it off the bench power supply. There's also this mains powered tuner unit which allows you to use the combination of the two as like the same as a domestic VCR. That wasn't working at the time I did that video, but I've since discovered that the problem was actually just another dodgy switch. This one does work after pressing it lots of times, so I can use this to power it rather than having to connect the bench power supply to the battery terminals. So I've taken the covers off and I've plugged it in, and that battery light's gone off. It's turned on. I'll see if it's somehow started to work. Put a tape in. No. Just cover this in case light's interfering with it. No response. Right, if we have a look at the block diagram, we can see that there's these two comparators. The inputs to them are both some ratio of the 9-volt supply, which is being used as a reference, and the 12 volts from the battery, which is being compared to it. This bottom one first. The reference from the 9-volt rail goes to the inverting input, and the comparison from the 12 volt to the non-inverting input. If the non-inverting input is higher than the inverting input, i.e. the battery voltage is higher than the level set by these pots, then the output will be open circuit. The voltage here will be pulled up by these resistors, and this LED will be off. If it drops below that level, the output will turn on, pulling the voltage down to 0 and turning the LED on. For the top one, it's the other way round. The reference goes to the non-inverting input and the comparison to the inverting. So when the battery voltage is high, the output pulls low, meaning this diode is reverse biased, and this data selector is just reading from the juice sensor circuit. When the battery goes low, the output is open circuit. This capacitor charges up through this resistor, the diode is forward biased, and the data selector reads the high voltage from that circuit. These two diodes and this resistor form an OR gate. Because the effect if the juice sensor is on or the battery is empty is the same. Stop the tape and disable operation. If we look at the schematic, it's basically the same. The main difference is we've got these capacitors decoupling the two voltages. That's to prevent momentary drops in voltage from putting it into stop mode. I think this is the circuit where we need to be investigating first.
Right, so this is the chip. It's a 2901 quad comparator. The top comparator, the one for the battery empty, is pins 6, 7 and 1. So pin 7 is the non-inverting input, which is the 9 volt reference. That's at 4 volts. And then this one should be higher. That's the 12 volt comparison, but it's not, it's lower. Not sure why that bulb's not coming on, but so why that's lower I'm not sure. On here, on the schematic, the readings what it's giving for this, for pin 7 they're giving 4.1, and then for pin 6 they're giving 5.0. Pin 5 and 6 are the same, and 4.4 for pin 4. That's 4.2. Pin 3 is the supply. 1.4. That's not right. 1.4. That should be like 12 volts or something. We see where it's supplied from.
So the supply for that chip is 10 volts, which is generated on the same board by this regulator circuit. It's very simple, just a Zener diode, a resistor to supply it, and a transistor as the output device. So this must have just failed because it also supplies that LED that's off as well.
So this is that transistor. You can't see it very well because it's behind this heatsink. But we've got emitter, collector, base. It's an NPN. So the collector should be 12 volts, which I think is just this 0.83. Right. Base, that should be 11.7. It's not. Obviously that's what should be 10. So the 12 volts to this comes from connector 6, pin 18. This is connector 6, pin 18, yeah, 0.83. It goes over to this, which is the audio and CPU board. 1318.83 again, and then it comes onto there from the bottom board at connector 3 pin 2, which is this. And 1, 2, this is 2.82. This is going to be a circuit protector in it, I can tell.
So that 12 volts comes onto the board at pin 18 of connector 6. That goes to the audio and CPU board, connector 13. That goes to connector 3 pin 2, which goes to the servo board, connector 2, where it passes through a fuse as it comes from the chroma board at connector 1 pin 1. On the chroma board, it comes via the power switch from the Y-amp board, the schematic of which is missing from this scan, but I think it goes to the connector and battery at that point. So I'm thinking it's likely to be this fuse on the servo board, F3.
Right, so this is the servo board. This is that fuse 3. It's open. Fuse 2's alright. Yeah, fuse 3's open. So that is a 2.5 amp fuse, I think. Yeah, it's 2.5 amp fuse, so I'll replace that and then hopefully we'll be back where we were before that fuse went. them belts are like. Right, that's the fuse. Right, so I'll try it again. Okay, so I'll switch it on now. The head drum spins up and then that battery light comes on. So I think it'll probably be back as it was. Alright, so the collector 12.7, this is the emitter 9.98 and the base 11.2. so that's that, so we can get back to the comparator circuit now. So on this chip, pin 6 is the inverting input of the battery empty comparator. They've got the voltage here on the schematic as 5 volts, it's 3.5. Pin 7 is the non-inverting input, which they've got as 4.1. That's about right. I mean, it's not variable anyway, so that's what it is, but it's roughly right. But that one's far too low. Well, let's try adjusting the pot. This is R45. That way it makes it go down. So even if I turn it right up, highest I can get it to is 3.8. So what's happening there? Is it the pot? R45's fed from R44. That's 3.8 there, which is at the highest I could get on the pot. On the other side, it's 8.7. That comes into this board at connector 6 pin 7. 8.7 there again. So I mean, I'm guessing this should be about 12 volts, I think, but it doesn't say on there, but clearly that's too low.
So this battery check line comes in at connector 6 pin 7 from the audio and CPU board, connector 13 pin 7. On that board it just goes across from connector 6 pin 9 from the Y-amp board. I don't have the schematic for that board, but if we look at the DC line wiring diagram, it looks like it goes off to the chroma board. It does also go to this transistor. On the chroma board at connector 39, it goes via this diode, which is where it splits off from the main supply. So chroma board connector 39 is the place to start, I think.
Okay, so we're on the chroma board now, pin 39. That's 8.7. So there's nothing between there and there, that, you know, between here and there, that's a problem. So what about the diode? That's that side. Hey? That's 12.29. That's 11.9, yeah. Is it just a bad print? No, it's 11.7. They're like a dodgy Just like a dry joint or something, I think. Yeah, it's gone to 8.7 again. Press down on that a bit. Now it's 11.7. Yeah, so it's just like a dry joint or a bad bit of print. So I'll just patch that up and then we should be alright. So this is a joint and it looks like it's slightly coming away from the print. I'll just scrape away a bit of solder mask. Not the best tip for doing this sort of stuff really, but be alright. Right, so let's see what happens now. Turn it on. That drum's spinning. And the battery light's not coming on. What's this? Oh. What's that voltage now? 4.72. Well, we'll have to set that up properly, but for now at least that is working. Right, I tried taping it but I forgot to record it. What happened was it loaded the tape and started playing, but there was no take up. It went into alarm mode with all the lights flashing on the front panel like it did when the lamp was blown in the other video. So I switched it off and back on again, and that fuse F3 blew again. I replaced that fuse and turned it on. It didn't blow, but it didn't unload the tape. It just went into alarm mode again after a few seconds. So I turned it off and manually unloaded it, and I'll show you what it's doing now. It weren't doing that a minute ago. It was going into alarm mode. Ah, there we are. So I turned it the right way up now. And if I press the eject button, you can see it doesn't eject. Now the reason it won't eject is because of the position of this solenoid. It's in, and that actuates the eject lock. It's permanent magnet type, so it's driven in one direction with a pulse, and the magnet holds it there until a pulse the other way drives it in the other direction, and the magnet holds it in that position. So if I pull it out, it takes a bit of force to get past that magnet. Eject it now. Right, now because this solenoid stays in position until it's pulled to the other position, it's not going to release automatically when the power gets removed like a spring-loaded one would, so it needs to be pulsed when the power goes off. This is a circuit that drives a solenoid. If this input's high, then this transistor turns on, which drives current into this end of the coil. It also turns this transistor on, which sinks the current from the other end of the coil and releases the solenoid. If this input's high, it turns this transistor on, which turns this transistor on. That drives the current into this end of the coil. It also turns this transistor on, which sinks the current from that end and engages the solenoid. The engaged side is supplied from the 12 volt rail, i.e. the main supply, but the release side is supplied from the 10 volt rail through this diode. This is a circuit to release it when the power fails. On the cathode side of the diode, we've got this big capacitor, 4700 microfarad. When the power gets removed, the 12 volt and the 10 volt rails will drop more or less straight away, but because this diode's there, that'll become reverse biased and that cap will stay charged.
The non-inverting input of this comparator is connected to the other side of the diode, so that will drop, but the inverting input will stay high because it's connected to the capacitor side. That will make the comparator output go low, which will turn this transistor on, make that input go high, and release the solenoid. Alright, so let's have a look at what's going on in this circuit. This is pin 1 of IC3, it's the output of it. I'll turn it on and then I'll turn it off and see what happens. So that does instantly drop, which is what it's supposed to. And then we've got the transistor X30, so look at collector of that. You should get a pulse, like a positive pulse. That's it on. And there is a bit of one, kind of brief, but it does go high. So I'll look at the bridge circuit. So that pulse drives the base of X23. It's a common, it's an emitter follower. So I'll look at the emitter. I'll look at the base first. There's a pulse there. And emitter. And there's a pulse there. They're not very big, these pulses. It's up to maybe like 8 volts or something. And about the collector of X22. This is X22 collector. And that's going up as well. Let's look at the actual output to the solenoid. Because what should happen is the emitter of X23 is connected to the base of X22, so when that turns on, when that point goes high, it should turn on X22 and pull the collector low and sink the current from the solenoid. This is the two solenoid terminals, two ends of the coil. So what should happen is the top trace should go high and the bottom one should go low. Both go high. So what I'm doing now is I'm adding the traces together and I'm inverting the second trace, so, well, the second channel. So you should get a pulse. Barely anything. So it looks like that transistor X22 isn't turning on. Have a look at the base of it. That goes up. And the collector does as well. So maybe that transistor's faulty. That might be what blew the fuse. So I'll see what sort of transistor it is and see if I've got a replacement. I'll take it out anyway and, well, test it. Right, well, it's very difficult to get to the other side of that board. You've got to take both boards off the bottom, this board off the front, and then pull that and pull this connector out. But anyway, I've got the transistor out. Let's give it a test. 2 resistors, yeah. So I've got to see if I have a look at the specs for this and see if I can find a transistor that'll do as a replacement. It's a 2SC2655 in one of these sort of long TO92 packages. So it's going to be a fairly high current one for driving that solenoid. So I'll have to see what I've got. So this is the closest thing I've got in terms of current handling. 2SD669A. That's, well, we are going into like TO220 packages and stuff, and it's a sort of smallish one, because it's a 2 amp collector current, that one. Although this one is lower, it's 1.5, but we'll see how it goes. I might have to get another transistor to put in, but try it out.
Right, so we've replaced that transistor. I'll switch it on, see what happens. We should get that top trace going up and the bottom one staying down. I didn't do it. Both went up again. I've soldered a wire onto there so I can probe off it. Get another go. Both go up together. It is at least not going into alarm mode now. So see what happens if I press fast forward or rewind, because it should send it the other way. When I do that, it should lock the eject. So it's done that. It's not fast forwarding though, but so it does work in that direction. I think it's trying to eject the solenoid. It's going to alarm mode now. One thing that is happening is that I keep not getting power to it, and I'm having to sort of flex the boards and stuff, so I think there might be maybe some cracked solder joints on some of these connectors, like these and ones on the other side. So I'm going to go through these pins of these connectors on here and on the other boards and resolder them, so hopefully any problems stemming from them are eliminated. Right, so I resoldered them points, and this is what's happening now. That drum spins up and it goes to stop and then goes to the alarm mode. Have a look again at what's happening with these transistors. So this is X23, this is the base. This is the collector, which is just connected to supply and emitter. And X22, this is the base. Collector. It shouldn't be going up. Emitter. That's connected to ground. Right, so it's doing the same in the other direction as well. If I start it up and I press rewind or fast forward, and that should make the solenoid pull in. So this is the emitter of X23. Press rewind. This is the emitter of X23. But it doesn't do it now. So yeah, there we are. And that's the collector of the other one, the X22 I think. I'll have to just check all these transistors, I think, because there's something going on. This is X23. That seems to be alright. It's a Darlington transistor, that's why it's got that VBE of 1.2 and like a ridiculous HFE. This is X24. So that one has failed. What is it? 2 to 3. I think that 3 is the base, I think. It's a diode from base to collector and then just open. I think that's the same type as that one that I've already replaced. So I should hopefully be able to replace it with the same type again. I replaced that transistor, X24, and I put that one back in that were alright. So, see what it's like now. If it's any better. I've done something. It's in stop mode now, that's gone high. That's like it's trying to pull it in. What about X22? And both high again. I pushed the thing in, the solenoid, as it were out. I'll see what happens. You hear it's kind of clicking like it's trying to do something, but I don't know. Alright, so I've just tried something and I think I might be getting to the bottom of what's going on now. This is X22, and if I put this other transistor in parallel with it and start it up, I've got the solenoid pushed in, so it should push it out when it starts up. Let's make sure it's making a decent connection. It has done. So I think what the trouble might be is that these transistors that I've used as replacements, I think they might not have enough gain. Now this transistor that I've just used here, it's got a lower current rating than the original one. I think it's 1 amp and the original one's 2 amp. So it's not really a suitable replacement, but I think what I'll do is I'll put it in anyway in replacement of them ones that I've put in, and then just see how it goes, and I'll have to try and get either the original transistors if I can get hold of them, or something more closely matching what the original one was. Although having said that, I think these are probably off eBay, so they might not even be what they say they are anyway, so I'll put them in and see what happens. Alright, so let's try it now that I've replaced these other transistors. The top trace should stay low and the bottom one should go high, and it should push the solenoid out, so I pushed it back in. It did do it. I'll push it back out, push it back in, and then see if it does it again. I can smell a faint burning smell, so something might have blown there. Just trying to push it back out to when I press fast forward or rewind, but it's not managing. I'll just try again. Yeah, there's a puff of smoke just come out and something's failed. And see what voltage it needs to push out and pull in this solenoid. I'm going to try it at different voltages. Like, I wouldn't normally do this where it's like in circuit, but because it's just that transistor circuit, I think it'll be alright. And I can replace transistors anyway. It's out at the minute. In which direction? Right, so that way I think must be to pull it in. Yeah, 8 volts, that's not enough. Try 8.5. That doesn't seem to be enough. Try 9. That's not enough. Try 9.5. That's pulled it in. Like the other. Out. Turn it down a bit. Try 9.3. That's just about enough. It's alright that way. Yeah, 9.3. Pull it in both ways. 9.2. So 9.3 seems to be the minimum. Right, so let's have a look at what voltage is actually across it. That's 2, 4, 6, 7, that's 7. That's about 7 volts, which not enough. So is that X24 not pulling down, or X21 not pulling up? This is, so this is X24. Comes up a bit, but not much. X21. 2, 4, 6. Yeah. So it's that X21 not pulling up enough. So probably that again might be a question of the gain. I'll try it with another transistor. Got another transistor here. That's done it, that. That's running in both directions. Let's see what voltage that is. That's about 10 volts. I'll put that transistor in. It's the same. I think I've already replaced this with one of these SB560s. So maybe this one's just an higher gain one. I'll put that in and hopefully it'll be alright. They're not the current spec what it wants, but hopefully it'll last long enough for getting the thing running. Right, well, I've replaced X21 with an higher gain transistor, so I'll see what it's doing now. That's about 9 point something or something. Anyway, it's enough to push the solenoid out. Pushes it out when you turn it off. When you turn it on from the disengaged position, it pulls it in and goes into alarm mode. some reason. See what happens when I start it with it pushed in. So it pushes it out and then pulls it back in again, and then goes into alarm mode. And head drum and capstan both spin up, and then it does the clicks. So I wonder why it's doing that. Like it thinks it's in some mode or something. I'm not sure what's going on.
I'm just looking in the service manual here, and it tells you what conditions make it go into alarm mode. So you've got 1, if the brake and pinch switches are not operated on or off within 2.5 seconds after the brake and pinch solenoid commands are sent from the CPU. The brake solenoid is operating, but maybe the switch contacts are dirty, so we can check that. 2, drum rotation stopped, absence of the flip-flop signal for 4 to 6 seconds in a mode when the head drum is supposed to rotate. That's not applicable because we're in stop mode. 3, take-up reel stops for 2 to 4 seconds in play, recording or audio dub mode. Same again, not applicable. 4, cassette lamp failure. And the cassette lamp hasn't failed, but we could look at that circuit that detects it to make sure there's no problem. 5, loading or unloading mode does not complete within about 6 seconds after starting. It is unloaded. We can check the unload switch, but it's not running the loading motor, so I don't think it's that. The brake and pinch switch are connected to pins 35 and 36 of the microcontroller. They're pulled up by these resistors, so they'll go low when closed. The cassette lamp's fed from this 10-volt rail. Then there's this resistor in series and this transistor that turns on to complete the circuit to turn it on. It also goes to the base of this transistor to a 10k resistor, which is high value so that not enough current flows to light the bulb, but it'll turn on the transistor, which will pull this point down, and that's fed to this data selector, so it can be read by the microcontroller. The unload switch is here. Again pulled up to 10 volts. It goes to pin 1 of the data selector.
Okay, I'll have a look at the inputs from the solenoid switches. The switch for the brake solenoid, that's connected to input A2 on the micro, which is here. So when I turn it on, it should be open, so it should be high, and then it should go low when the solenoid pulls in and it closes the switch. So I'll try it now and see what happens. It's high. Right, so it's not, kind of pulls down slightly, but I think that might just be the rail dropping a little bit. Check the switch itself. This switch here, push that in. It is connecting. I'm not sure. It ends up at that audio board eventually, but I'm not sure where it goes. Follow this wire. There comes to this, is it? Is that it? That seems to be connected. Let me try it again. Might have been that socket maybe. Right, so I'll push the solenoid in. Try again. Yeah, so it now seems to be working correctly. It's not going into alarm mode. So that seems good. I suppose the next thing to do is to try it with tape, see what happens. Put tape in, switch it off, switch it on. Try rewind. It's not rewinding. Fast forward then. That play. Oh, it sounds like it's loading. It's leaving a loop of tape out. Right, so it did load the tape, attempted to play and left a loop of tape out. It won't rewind or fast forward, so have a look at what's going on with the reel motor and the idler and what have you.
This is a circuit that drives the reel motor. This section's a bridge circuit similar to what's used for the solenoids, so it can drive the motor in either direction. The speed needs to be controlled because it's used for forward and reverse picture search as well as normal rewind and fast forward. It also acts in place of a take-up clutch in play mode. So the way this is done is where with the solenoid bridge the circuit is supplied from the voltage rail. In this one it's supplied from a variable voltage. That voltage comes from a chopper supply. This is a chopper transistor and it's driven by a square wave with a variable mark space ratio from this comparator. The inputs to the comparator are a DC voltage from this op amp and a sawtooth wave from here. So when the DC voltage at the inverting input is higher than the voltage that the saw wave's currently at, the output will go low and turn on the transistor. The saw wave rises, and when it gets above the DC voltage, the output goes high and turns off the transistor. The ratio of high to low will be proportional to the input voltage, and because of this inductor and capacitor, that gives the DC voltage for the bridge circuit supply that's determined by that input voltage. There's a number of different input voltages set by these pots. Which one gets to the op amp, that's determined by the microcontroller and this decoder. There's a 4-bit number from the micro, and that's decoded by this chip to select one of these outputs. That turns on one of these transistors here, which connects its respective pot to the input of IC8. Right, so I'm looking at the servo board now because I'm going to try and see what's going on with this reel motor, and I've noticed a couple of components whose pads, I don't know if the pad's lifted off because it still looks like copper under there, but like the solder joints come away. There's that one. There's this one over here. I'll solder them back on and then start looking. Right, so I'll first check the outputs of the bridge circuit. Put it in fast forward. That's IC28, IC27. No joy there. I'll look at the collector actually as well.
there's no supply by the looks of it to that bridge circuit. So IC10 pin 3 is the drive. It comes on to turn it on, but then doesn't do anything else. Let's have a look at pin 2 then, which I guess is this. Yeah, that's got that sawtooth wave. And 2 volts. Not sure how big it's actually supposed to be. And pin 1. Right, so that's miles above that thing, I think, or is it? No. So I'll check both inputs at the same time and see what's happening. That's completely above that. So if that's on all the time, then that means that the output, yeah, that was low. I should be turning on that transistor, which is X49, which is this one here. Is that a bit loose? It seems to be like... What's going on there? Let me resolder this transistor before I do what else. I've resoldered it, get another quick try. I seem to start chopping then. That's the collector of that chopper transistor now, but it's still not doing anything. That goes to L1. Well, I can just check the emitters of these again, can't I? X27, X28. See if they're getting the proper voltage now. They are getting the voltage. Emitter of one, emitter of the other. So in theory that motor should be running. So it might be a dodgy connection like what was causing that thing with solenoid before. So they go to these connectors here, 102 and 103. And started running then. I like that thing on it. Alright, try again. That's working. Oh, is it that solder joint? Is that what's causing it? It looks a bit iffy, that actually. I did resolder these, but it don't look like I've done a very good job on a couple of them. I'll have to check them. It's the second one here. You can see it's like not particularly good. That fourth one, actually I'm just going to go through and redo these.
Okay, so the real motor seems to be working reliably now. In terms of the motor actually running, I might need to clean or replace the idler tyre, but I'll get to that when I look at the belts. The input from the solenoid switch to the micro still keeps playing up, so I'll have another look at that now. So this is that switch, and this wire goes to the micro. The other side of the switch is connected to this base plate, which should be connected to ground. It is. But how is it connected? It must be this wire. Well, that's connected to the other side anyway, but that's soldered directly to the thing. So I would follow that wire, see where that goes. Yeah, that's it. Where does that go? That goes to this. Pull that out. Yeah, so that's that. That's not connected to ground anymore. So I wonder if it's this connector or the socket. This is plugging into this front panel board. So either this connector, that's the points where it's soldered to, and then this is connected to the other boards by these connectors here. So it could either be that or this. Resolder this, and it looks alright, but it's hard to tell. And I'll give these a bit of a clean and reseat this a few times, just so okay, to make sure it's got a good connection. Right, so I've resoldered that and these connectors here, and I've pushed that in and out a few times to try and if there's any tarnishing on it or anything, to kind of scrape it away, and hopefully it's got a good connection now. So hopefully that'll be reliable. We'll see as we go on. So now that the real motor's working, let's see what it's like mechanically when I try to play a tape. It did load up before, but because the real motor wasn't running, there was no take up, and it left a loop of tape hanging out. So we'll see what it's like now. I'll press play. It's not loading now. There's a loading motor running. Oh, what's it doing now? Right. Does look like it's running, though. It looks kind of jerky, but the belt's slipping. Right now. What's it doing? Right. Struggling. Fast forward it a bit. It starts off well. So it just seemed alright, I think. It might just be this tape, but it probably could do with a new set of belts. Although it's running quite well to say it's just got these old belts on. I ain't changed them. I don't think I changed any belts in that other video. Okay, I'm going to take the cassette housing out so that I can clean the idler. Get a bit of a clean out while I've got it up, and all this bits of, I don't know what it is, bits of black stuff. All that. I've got some platinum clean now. I'll put a bit of grease on these tracks where this thing goes. Try to put it on caps though. Right, now this has had a chance to dry out a bit. I'll put it back together and see what it's like. I'd be running continuously. Just dual warning. That braking's still not very good. It seems to be running pretty well. It's better than it were before. I think this tape has got some bits on it where it's difficult to run, where it struggles a bit. But once it gets past that bit, it's when it's rewinding really. Once it gets past that bit, it's alright again. So I think next thing to do will be to try actually playing a tape and see what the picture's like. But there is that issue with the brake. It's the brake on this reel. I could see pad were quite worn down, so I might be able to put a new bit of felt on it or something, or whatever it is. I'm not sure what they're made out, to be honest, but we might be able to put a bit on of something to work as a grip, a bit of foam rubber or something. So it starts to slow down there, and that's speeding back up again, and that just carries on spinning. Right, I've got a test tape in, so I'll press play. That looks like there's a capstan servo fault. There should be a tone on this, but it's not really coming through. It is going through the thing though, it's going through the RF, so that might be part of the problem. I'll try a different tape with some torquing or something on. Yeah, definitely a servo fault. It's running far too fast, as you can hear. So I'll have to look at the capstan servo. It's probably running flat out. There's probably an input missing or something, I would think. Either that or, well, I don't know, something's failed. But right, I think I'm going to leave it there for this video, and then in the next part I'll have a look at the capstan servo and try and work out why this tape's playing too fast. So bye for now.